u Hrvatskoj kontroli zračne plovidbe. Tome je doktor znanosti Damir Barčić, predsjednik Hrvatskog agrometeorološkog društva. Za kraj pozdravimo Damira Zmajića, višeg stručnog savjetnika za unapređivanje poljoprivrede u Gradskom uredu za gospodarstvo, ekološku održivost i strategijsko planiranje. Svima sada ću zamoliti Vesnu Đuričić, predsjednicu Hrvatskog meteorološkog društva, da nam se obrati s nekoliko prigodnih riječi.
Dobro jutro svima. Pozdravljam vas u ime organizatora meteoroloških izazova 9 Hrvatskog meteorološkog društva i ovi svi ostali uzorici koji su poimence bili najavljeni su organizatori ili pokrovitelji. Oni ćemo se isto obratiti sa riječi dvije. Drago mi je da smo se okupili u popriličnom broju, iako imamo zapravo 109 prijava, ali neki dolaze kasnije, neki dolaze možda samo sutra, tako da nisu sad odmah svi tu. Tema je izuzetno interesantna u ovoj eri klimatskih promjena, od posljedica klimatskih promjena pate zapravo svi segmenti društva, pa tako i poljoprivreda. A s obzirom da nam je to baza za hranu i sve, onda je to vrlo važna tema i to mi je zapravo pokazalo i veliki interes i broj prijava. Konferencija se održava uživo i online. Snimat ćemo sve, pa će snimka biti na YouTube kanalu Meteorološkog društva, tako da oni koji ne mogu niti danas biti prisutni, niti uživo, niti online, mogu kasnije pogledati snimku. Nadam se da ćemo imati uspješan rad ova 2 dana. Dosta ima predavanja, 48 usmenih predavanja, 12 postera. Posteri su u prostoru tamo gdje ćemo imati pauzu za kavu, pa onda možete razgledati postere i razgovarati sa autorima koga šta interesira. Još bih samo htjela na početku reći da tehničke neke detalje. Molim prije svake sekcije sve koji imaju predavanje u toj sekciji da Vjeranu Mađareviću, kolegi tamo u ćošku, donesu svoje predavanje da bude sve spremno. I nadam se da ćemo se vidjeti na svečanoj večeri u restoranu Maksimu danas na večer u 8 sati. Ko hoće ići, nek se prijavi na recepciji. A sad ne bi više duljila o samim izazovima, možda samo da naglasim da su nam generalni pokrovitelji Ministarstvo poljoprivrede i Ministarstvo znanosti i obrazovanja, a pokrovitelj grad Zagreb, tako da žao mi je što nema, osim kolege iz grada Zagreba, što iz ministarstva nema nikog prisutnog da malo čuje od struke šta se dešava na tom području, ali evo, nadam se da će rad na konferenciji biti uspješan i da ćemo one glavne ciljeve, a to je razmjena znanja i među nama znanstvenicima i sa korisnicima meteoroloških podataka, da ćemo te ciljeve ispuniti i da će konferencija biti uspješna. Hvala.
Hvala lijepo. Sada bih zamolio Mirka Planovića, dekana Prirodoslovno-matematičkog fakulteta, da nas također pozdravi.
Hvala lijepa, poštovani gospodo, kolegice i kolege. Pozdravljam nas u ime fakulteta koji je zapravo domaćin jednog odsjeka geofizičkog, kojim su meteorolozi struka, i vrlo dobro surađujemo i sa odsjekom, i sa meteorolozima, i sa Državnim hidrometeorološkim zavodom. I stvarno nam je drago da se ovaj skup odvija. Imali smo nedavno jedan skup o klimi na fakultetu zajedno sa većim listom. Bilo je iznimno dobro posvećeno i medijima poprečeno. A osim toga imali smo i predavanje neki dan o klimatskim promjenima, minju, laniju i tako dalje. I sve je bilo jako prekurno i posjećeno. Tako da to su stvari koje ljudi zanimaju. A još bi samo kratko, ako smijem, jednu priču kratko ispričao, koja zapravo ima veze sa sigurnosti ljudi i hrane koje na danas govore. Dakle, 87. godine u jednom Manhattan hotelu su se skupili dioničari jednog dioničkog društva koje se bavilo proizvodnjom aluminija. I sad, zadnjih godinu, dve su počele neke turbulencije u kompaniji i odlučili su promijeniti vodstvo. I svi su se skupili jer su najavili da će predstaviti novog CEO. Taj novi CEO je bio nekakvi bivši državni dužnosti. I kad su došli, svi su htjeli čuti kad će to sad biti glavni fokus kompanije. On je rekao, gledajte, ja ću od sada se fokusirati na sigurnost. Ovo su svi ostali pa, kao kako je sad sigurnost, nama trebaju više novaca, ne znam, bolji projekti i tako dalje. Uglavnom, on je, nakon što je došlo to predstavljanje, dioničari su rasprodali mapu dionica, što je ovaj pitanje neće ući da odresti. A oni, to je bila najgora moguća odluka koju su zapravo napravili, jer on u 5 godina udvostručio vrijednost kompanije. Sad, zašto to govori? Zato što kad se fokusirate jednu stvar koja je jako važna, onda se svi drugi procesi nekako poslože. On je uspio napraviti lance dorade, pa je uspio kazniti oni koji ne javljaju da imamo sigurnosne probleme. Uglavnom, sve se posložilo dobro i kompanija je procvjetala, fokusirajući se na jednu važnu stvar. Tako da mislim, ovo što ovdje danas radite je jako dobro, jer se možda, iako nema ljudi iz ministarstva, država malo posloži i druge države kad se to neće biti. Evo ja želim jako uspješan skup i hvala vam što radite tako zanimljive da se stavite životno.
Hvala lijepo iskustvu, profesoru Bajnicu, a sada bih molio Danijela Belčića, pročelnika geofizikog odsjeka, da nam se također odati.
Hvala. Pozdrav na sve prisutne. Pošto vidim da u publici imamo i neki koji vjerojatno ne znaju hrvatski jezik, prebaciti ću malo na engleski pa da predstavimo njih. So I'll switch to English now just for our guests who don't understand tradition. It is my great honor, of course, to welcome you all here and to be a representative of the department and faculty who are co-organizers of this manifestation. Now we see there is a number 9 here, which means that this is the 9th time that this will be happening, and this is a great news for everybody, because I really want to congratulate the organizers who have been very persistent in making this happen for now 9 times, and now I can say that it's already a tradition. So I'm very much looking forward to the future of this kind of meeting, and of course of our field. Now my speech writer, probably somebody here, he just told me in front of the room what I'm supposed to say. And he said, you're supposed to say that meteorology is important. So I said, meteorology is important for all of you who don't know. But I have to say one more thing, and that's my uncle was actually, how do you say this in English? Agronome. But he was in the field of agronomy. And when I asked him why he chose that specific profession, he said, well, you see, when all other areas of science or research fall down or are become obsolete or uninteresting, production of food will always be important. So he said, this is something that I'm certain will survive everything else. And this very much points to how important agronomy is. And then by connection, it also shows how meteorology and climatology are important in informing whatever happens in agronomy. And I'm very, very happy that we have this combined field, which is called agrometeorology, which shows the importance of combining the fields that we hear both fields living. So, to cut it short, I want to welcome everybody and thank you all for coming, and I wish you a very, very great manifestation, great conference, and hope also to see you next time. Thank you.
Thank you. Da, meteorologija je važna. Hvala Danijel. Molim i sada reklamu ravnateljicu Državnog meteorološkog zavoda, Ravnice Čampice, Ravnice zavoda.
Hvala. Dame i gospodo, dragi kolegice i kolege, izuzetno mi je drago da vas mogu pozdraviti ispred Državnog hidrometeorološkog zavoda koji je suorganizator ovog važnog, evo čuli smo sad od profesora Belušića, 9. po redu meteoroloških izazova. Postoje jedna velika tradicija. Izuzetno mi je drago da mi kao Državni hidrometeorološki zavod, kao netko tko brine o meteorologiji, dakle o vremenu, o klimi, o vodama, o tlu, ima prilike ovdje sudjelovati. Prije svega sudjelovati preko naših agrometeorologa koji vrijedno rade, prate sve podatke, klimatske podatke, daju informacije i surađuju sa ostalim sudionicima u poljoprivredi. Ono što je već neću ponavljati, vrijeme je izuzetno važno upravo za poljoprivredu koja je najosjetljivija, ja bih rekla, na sve klimatske, vremenske ekstreme. I izuzetno je važno biti u tijeku, davati rane najave kako bi se naši poljoprivrednici, ali i svi ostali sudionici u proizvodnji hrane mogli na njih pripremiti i prilagoditi. Ono što je izuzetno važno ovdje napomenuti, to je da Državni hidrometeorološki zavod preko svojih motriteljskih mreža, evo, upravo smo pri kraju velikih strukturnih projekata u okviru Metmonika gdje se unapređuje meteorološki monitoring, pri tome i isto tako monitoring, dakle dodatna mjerenja i stanja tla, dakle i temperatura tla i stanja vlage u tlu, što će dati definitivno jednu dodanu vrijednost svim našim dosadašnjim rezultatima na području agrometeorologije. Evo, neću puno duljiti, zaželjet ću i sigurna sam da će i ovaj skup izroditi nove ideje za buduće suradnje i ja se nadam vidimo se na idućim meteorološkim izazovima. Hvala vam lijepo.
Hvala vam lijepi, on pitanje. Sada molim Igora Konca iz Hrvatske kontrole zračne plovidbe da nam se također kratko obrati.
Hvala. Dobro jutro, dobar dan svima, drage kolegice i kolege. Pozdravljam vas isto tako u ime Hrvatske kontrole zračne plovidbe, za eventualno oni koji još ne znaju tamo se nalazi služba zrakoplovne meteorologije u Hrvatskoj. Znači nisam možda direktno povezani sa glavnom temom ovogodišnjih izazova, no svakako nisam jedan od dovoljnih točaka svi mi koji se bavimo meteorologijom u Hrvatskoj. Jedna od određenih točaka, znači zrakoplovna meteorologija kao i agrometeorologija su, ajmo reći, pod velikim utjecajem klimatskih promjena i vrlo je važno da na vrijeme reagiramo na sve što se događa kako bismo mogli što bolje surađivati s našim korisnicima, koji su, ja mislim, druga dodirna točka svih primijenjenih grana meteorologije. Strašno je važno da komuniciramo s korisnicima i da znamo kako na vrijeme i pripremiti tu informaciju, kako bi ona bila iskoristiva s druge strane. I još jedna stvar, znači, ja sam i osobno povezan donekle s agrometeorologijom kao jedan amater, jedan gledar, tako da mi je ovo područje meteorologije vrlo bitno. Ovo nije moj druga da se izjavio nešto slično pitanju. Želim vam svima ugodan i koristan skup i još jednom se pozdravljam.
Prvo bih zamolio doktora znanosti Damira Bačića, predsjednika Hrvatskog agrometeorološkog društva, da mu se također zavisno riječ.
Dame i gospodo, kolegice i kolege, srdačno pozdravljam u ime Hrvatskog agrometeorološkog društva, ali i Fakulteta šumarstva i drvne tehnologije. Naime, ovo iznimno važno područje agrometeorologije povezano je sa silnom meteorologijom, pa stoga i smatram kako možemo dati doprinos našim primarnim djelatnostima, kako poljoprivredi, tako i šumarstvu. Naravno, nadam se da će tijekom ovog skupa doista doći do i suradnje intenzivnije, ali i razmjena ideja kako bismo u konačnici mogli doista odgovoriti izazovima ovoga vremena i naravno prilagoditi se nečemu što evidentno nas u budućnosti očekuje, a to su određene promjene, nadamo se samo da će biti što je moguće blaže. Evo, s tim u svezi i naravno svima vama srdačno vas još jedanput pozdravljam i puno uspjeha u radu ovog znanstvenog stručnog centra. Hvala lijepo.
Hvala svim govornicima na lijepim riječima i pričama, a molim sada Vesnu Đuričić, predsjednicu Hrvatskog meteorološkog društva, da odgovori ovaj skup.
Evo mene još jedanput i nije zadnji put danas vjerojatno. Evo, čuli smo pozdrave svih suorganizatora i ja se također nadam da će ova razmjena ideja, razmjena rezultata znanstvenih istraživanja dovesti do nekih možda novih suradnji, do novih projekata koji će opet rezultirati sa poboljšanjem prilagodbe na klimatske promjene u području agrometeorologije, ali ne samo agrometeorologije, jer imamo i druge sekcije koje nisu direktno povezane sa agrometeorologijom. Sad bih zamolila predsjedavajuću prve sekcije, gospođu Andreju Sušnik, da zauzme tamo svoje mjesto. I mogu odmah pozvati prvog pozivnog predavača, doktora Žana Hušara, da dođe za govornicu.
Hello, good morning. Nice to be here again. I see some familiar faces in the room. And first of all, thank you, KRAŠ Meteorological Society for this kind invitation. I'm very glad to be here. I remember I was here one of the previous meetings, it was in 2013, and I was talking about fog at that time. So now it's the opposite, we talk about the data constellation, and how is the water, in a different aspect. So today, in the half of an hour, I will speak very large way, and I don't get the last one to the fact. So what I will talk about today is an effort that it's still going on. It was initiated by the Meteorological Services of France and England because they wanted to improve the representation of evaporation, data constellation in their models, because they were having problems with two things. The first thing was how to introduce the human management issues, so how to introduce in the model dams, irrigation, canals, etc. And how effective irrigation is not, because it depends on individuals. It's not easy to put in models. And on the other hand, the other thing that we wanted to investigate was if arid and semi-arid regions were well represented. And well, what you see here is what I will explain today is a paper that we are ready to submit. It still has to go through the review process. Essentially, what I will show are observations. Only observations. And kind of observations will speak by themselves. You don't really need a theory to be aware that you have a problem. So everyone must think and can think about what he or she will see today is in the reconstruction, in the previous reconstruction. So these are some colleagues. And here, well, I have a surprise because some figures have disappeared in the transcript. But what we see in the top is that we go towards more aridity in reality, implying more intensive water management almost everywhere, irrigation, and the extension of dry rainfall. The places that were not dry will become dry. So what I had here on the left side was how the precipitation is diminishing with time. So that there was a change between the beginning of the 20th century and the beginning of this century, recent years, and you could see that. I wanted to show that Croatia is experiencing less according to this analysis. And what we really can see in the right part is the projection for 2050. And you see, in this paper we talk about the winter half year and summer half year. You see that in the winter past year, the yellowish and green and orange and red colors mean less precipitation, and you see that in the summer the situation will change a lot. In particular for this place of the world, you don't seem to be much affected in the winter, but things are changing in the summer. So according to what I was telling in the beginning, these two main institutions initialized this effort, which is called the land surface interaction with the atmosphere over a semi-arid environment, and they put the Iberian here because they pre-selected the Iberian Peninsula for this study. And then they got in contact with the local community and all the interested parties, and finally we got a multinational experiment. And this took place in summer 2021, just after the pandemic. So we had some problems to start, because we had to start in April, but we couldn't travel. So finally we started in June. And instruments were left there until September, and we had an intensive period in July. Okay? So the outline is that first I will just tell you about the campaign, then I will show you the difference between the observed water transpiration depending on the type of surface, and if I have time I will continue with some other issues, but if I don't have time, we may comment here. So you may recognize this place, Barcelona will be here. Okay. Madrid will be here, Toulouse here, Marseille. So this is the Ebro basin, and you see these are the Pyrenees, these are the Iberic Cordillera, and these are the Catalan Costa. So this is making a triangular shape basin, almost close. It used to be a sea. And this is why it is a very saline, very saline. And at some point it broke the mountain range by the sea was broken, and the river was formed to this narrow water from the Mediterranean. So essentially it is kind of a container of Earth. It is a very dry place because the Atlantic fronts lose all their water as they cross the Mediterranean Peninsula, but the Pyrenees are the water power. So there is quite a lot of precipitation in the Pyrenees, and there are many dams in the river, just in the Pyrenees, and from these dams there are canals that conduct the water to the plain. So these canals, this makes a small slope to the east, and the canal, you can see the trace here, the canal. So the canal is irrigated by gravity. So you have irrigation to the west part of the canal, and the east part of the canal is not irrigated. So it makes a clear contrast, and the campaign was made putting instruments in this side and this other side. So you see that this is approximately a square of 25 kilometers long. And the other thing is that you can see the topography here, and even if the Pyrenees are here, they are not the most important topographical feature, because there are lots of mountains in between. Instead, this humble mountain range here, topping up to 1,000 meters high, this is the one really driving the meteorology, because it generates upward flow, downward flow. It is in the way between the sea breeze and the interior of the basin. So this is where we make the distribution of the different stations. So we have one main station here in an irrigated alfalfa field, one main station here in a rain-fed fallow field, so no cultivated. And then here we have a heterogeneous irrigated site, and here we have a little lake. So we were there for several months, but in the second part of July, we made extra measurements, like soundings, we installed geologic systems, and there were aircraft operations. NASA came in the aircraft, so it was quite a big thing. This is the weather that we had. So it was a
essentially sunny with two rainy days. With them up here. What you have in the lower, in the x-axis is the day of the month between 14 and 13. So you saw that you had increasing temperatures. This is the average of all these stations. There was another deviation. The specific humidity was quite high during the campaign, and this is because the sea breeze brings you moisture. So even if it is very dry locally, you have moisture because it is adapted. Okay? So there is no limitation, there is no exception. Atmospheric water demand here. And the wind speed was varying because we had the sea breeze coming this way and making some kind of eddy. So it here was more windy here. And you see that this is a lot of heterogeneity in a very small domain. Okay? So, well, this is more or less the frame where this data was taken. Okay. So here you see some of the measuring sites. Okay. So this is the reference site, which is a alpha site. This is the site which was followed at different times of the year. This was measurement of Renato Loccia. So this is the equivalent system of this. Under this there was a limiter, which is a method of measuring a rapid respiration by changes of weight. This was a grass field which was set in purpose for the campaign. So we planted about 30 by 30 grass field. It was intended to represent the average circle to calculate the reference of the potential of the conspiration. It was intended to see it. Okay. And then we had a lake, which is an artificial lake. So it is the canal keeps it to the constant level. But it's quite long, it's more than 1 kilometer long and 500 meters wide. So here you can see some very clear differences for one particular day. This is the irrigated field, and what you see in yellow is the net radiation. Okay. And here is the arid field, the fallow field, and you have also net. The first thing to look at is that for the same day, the net radiation in alfalfa is much bigger. I would say 15% bigger than the net radiation in the dry area. So, and this we will see afterwards that it happens regularly. So we have more net radiation over 30 by 50. And I think this is because of two factors. The first factor is that the albedo is lower, so there is that effect. And the other factor is that the irrigated areas are cooler, so they emit less groundwater radiation. So these both factors combined finally lead you to have more net radiation in the irrigated areas than unirrigated areas. Then you see the blue line is the rapid respiration measured by the kinetic covariance system. And in the irrigated field, almost all the energy goes into rapid respiration. While in the arid field, there is not a lot. Okay. And you can see here that there is a moment in the afternoon when evapotranspiration is larger than light radiation. So we lose more energy by evapotranspiration. So we cool more by evaporating than heat by solar radiation. So we find ourselves having fairly stratified conditions in the late afternoon, which was quite a surprise, because we didn't expect that. Well, I don't know if you expect it. We have to rationalize it. Then you understand. You have to understand what is going on. And this is illustrated here by the gradient, because when you have this phenomenon, and you're having a lot of evaporation cooling, and then your grass rising of temperature becomes positive negative in the fact that you are not transmitting heat to the atmosphere. And this is what you see, the gradient is concentrated when the gradients are negative in the daytime. So only sigma will be irrigated, right? So it is unstable for sigma, and when you go to the other place, it is unstable for sigma. And these are for two sites that are 10 kilometers away. So you can imagine that the boundary layer will be very different. You can imagine that the convective boundary layer is much more in one side compared to the other. And this is something that is currently being studied in numerical simulation. How this difference in the two atmospheric boundary layers finally generates a local circulation. And this local circulation induced by the irrigation. So here I don't pretend that you follow along these lines, but it is just the expansion of the previous line. So you see here that the differentiation, and what I can say, this is the evaporation. What I can say is that the irrigated stations have much more water consideration than the grass. What is perhaps the biggest surprise is that the lake is in between. So the lake is evaporating less than the irrigated area. And we shall deal with that. This is H, this is the sensible heat flux. Of course, the sensible heat flux is larger for the arid parts, and this is smaller for the irrigated parts. But there was one day in the campaign where we had a very strong warm advection from the Sahara, a very warm condition. And that particular day, this is the day, we had a lot of evaporation, and we had negative sensible heat flux. A negative sensible heat flux means that the day it was warmer, we had stable stratified conditions over the irrigated fields, while the non-irrigated fields doesn't affect. And this is because in very warm conditions, what we have is a very stable stratified surface and negative fluxes. And this is what happens most of the time, almost zero of negative fluxes over the lake. So over the lake, what we have is the evaporation in this case, because there is no transpiration from a water surface, the evaporation is restrained, because in fact, over the lake, you have stable stratified conditions in the lake. So I think this is behind why we don't use anymore these evaporimeter containers that we used to use in the 60s and the 70s, because it is not really representative of what we want. And here you also see that there are very, very big differences in the net radiation. So it goes from 450 to 800 parts per meter in net radiation, which is the basic part of what is going on. Then we have also a large difference in the ground into the surface, into the ground flux, and what happens is that the vegetated surfaces have very small ground fluxes, because of two reasons. First, they shut. Vegetation doesn't allow radiation to come in, but it also acts as a damping layer for the transfer of heat. And then, if you add up all these terms, they should flow in the ideal world, and they don't. So it is a well-known problem that the balance of energy is not closing. There is models before the closure, but not in observation. In observation, there has been a lot of research going on why this is not closing. If you are going to 2010, and it is not closing essentially because you are not measuring the same thing. So you are not looking at the differential layer, but you're looking at the volume, and you're measuring in a different places in the volume. So there are things in between that are not represented in these terms, especially storage. And the other thing that happens is that for this to close, the station should be in a homogeneous place. And these stations are not, but almost no station because there is a little power right? So this is the second and the third. So the main reasons are storage in the element of the volume, heterogeneity, and the instrumentality. So it's not the same to have a measurement there and to have it storage to the ground, you have different curves. And these are the imbalances that you see. And you see that in general, the imbalance is much bigger in the related areas, even if they are larger fields and more homogeneous. So this is pointing to the storage of the main problem of this thing. Instead, the added part has very small imbalance, is a very homogeneous field, and this is probably the baseline of what you can have here. So you can see some numbers, if you want to see some numbers, they are here. It is not that interesting to number by itself, but here I have separated these in three parts. The first part is the irrigated fields. So you see the values of the rapid transpiration, about something over 200 in general. You see the values in the irrigated, in the rainfall area, something below 150. This one is a little bit higher because it is the ability of the rainfall area. This one is higher because these are almond trees, and the water table was high, so the water trees can pump. So this is why you have larger water transpiration. And here you see the value of the lake. Okay? And this is how the blue lines are how the water transpiration varies between the sectors. So it's quite drastic. So you go from 500 to almost nothing. And then the reaction of the other things. So you get net radiation, and net radiation has to be distributed in evaporation, heating, and ground floods. And the slash part is the imbalance. In the lake, we don't have to put the ground to flood, so this is taken into imbalance. And what you see in the lake is that most of the energy goes into stored into the lake because almost everything is imbalance. So how much you have left? It's 15 minutes. So sorry for that. It is too small. Well, this is for the night time. And the night time is easier because in the night time the plants are under the stress of the solar radiation and this is still heat. And because we're talking about July instead. So the first thing that you can see to start with is the sensible heat plant. And you see that the scales have changed. So for all the fields, the sensible heat plant is negative. Meaning that for all the fields, the temperature is colder than the other one, except for the lake. The lake has a warmer temperature than the other one. So you have turbulence, you have shallow convection, you have mixing. And this mixing mixes ocean and water vapor. So we have at night, and this is a logarithmic scale, we have that the lake is operating more than 100 barrels per minute at night. It doesn't operate the same at night. And this is something that we really don't know. It is our lake. You know, something in the lake. And so that indicates that a lake is very similar in a landscape. And it is not useful to be taken. Then for the evaporation, here at night we start to have instrumental time because you see it is a 10 basket per meter. The basket per meter is very close to that. To the value of the evaporation and so all these values here are low, so I think that the only thing that we can do is say they are low. But you don't really half the light is very better than the other one, more or less. And at the end, what you conclude is that at night, essentially you recollect everything. Except for some days, when you go above 10 pascals per meter, this day in particular is done at night, and then it doesn't. And for this particular situation, so wet soil on the roof, on the roof, in this particular condition, you really have evaporation. But as we said also that this were conditions in the summer. My affirmation is valid for this. I will try to modify this tomorrow. So again, what you can see that essentially here what you can see that are the same numbers. Here there are not many differences. So the contrast seem to vanish at night. At this contrast, not this contrast that we have seen in the day, they are not just important at night. But what we see is that the event parts in the circle, they tend to have some evaporation at night, while the related areas are very little. And this is still a very immature work because we have mostly concentrated in the daytime. Nighttime evaporation is kind of for that real problem, but it needs attention. But as you will see later, it is true that we are thinking about daily value and annual value. It is essentially 10% of the total evaporation that the annual scale. And this is not normal. It is normally less than the average of certainty of the volume that you are obtaining. So at this point, if you are producing a new part, it is going to be less than the uncertainty that you have to make your decision what you put there. But there is a community of evaporation. Transpiration at night, so this at some time. So this was the generous. So we have different fields. So this was a carbon field, this was an meteorological field, this was a glass part, and this is a scintillometer. System of the mix. And the field is going to be radiation. Can be all particles. So the scintillometer gives you instantaneous values for a spatial average. You can make average temporarily, and you can compare this with individual parts. So this is something that is still also on the development. So you see the scintillometer is here. It's in the line here. And you have several of the other stations for comparison. So this is the dry area, this is the lake, this is the outdoor, this is grass, and this is the table and particles. So you see that they will be able to use the reference now formulation. Normally you are using a high value a top value for the ensemble. There are some things here that are interesting to discuss, but in particular, I think it's worth discussing in this field. You remember I showed that there was a ricovariant system on the top of this. Okay, this ricovariant was on over a decimeter, a big decimeter, 10 meters square, with 40 events. And that was because it was the Research Institute of Agronomy in Catalonia. And then there was another decimeter, 100 meters away, exactly the same, but without an ricovariant system on it. But we could obtain the evapotranspiration from the limiter. And the difference between these two limiters was that while one of the limiters was receiving as much water evaporating, so they were irrigating as much water as 50 potential evapotranspiration, the other one was only receiving 60%. So the fully irrigated atom is one evaporating and fully, and this is the line. It's close to the second. Instead, when the trees have to do some work with the stomata, to relate to the evaporation, these trees were operating much less. And why is this relevant here? Because you don't irrigate the same everywhere and at the same time. So if you irrigate by flooding, you flood one day and then you water. So the first day, you have to get water, then the water goes down, and you can cut some water available. So the tree has to regulate. Evaporation is the second part. So this introduces a lot of heterogeneity. Because these farmers have irrigated today, the other farmers have irrigated days. So introducing this kind of irrigation heterogeneity, which will put this difference about 400 to 300 passes per meter, 100 meter distance. Okay? So this is interesting, and this is very difficult to get off. And this is the point where I was trying to go. So since this was initiated by modelers, they wanted to see how the models perform. So this is what the observations do. And this is the two models that are currently participating in Horizon C. And to do this, they have to make a choice on what to intercompare, because you know that normally the model we use tiles. And the tiles are correspond to different types of surface. And they have to select the plots corresponding to the closest. Imagine that you have a lake, and that you have a bare soil, and that you have irrigated area. So you will only compare the irrigated value from the model with the irrigated field from the model. So you are not clicking the model. So here you are comparing the closest possible patch. Okay. So, and what you see to make a long story short is that the observations will show a variation in the model's done. And the model's done because they have a lot of difficulty in having a representative patch. So, for instance, there's an edge, if it is irrigated, it has to be C4. They don't have C3 plants. Why? I don't know. And instead, the Jews, if you take a topic model, yes, and do the separation, so the results are not good. So, this now is the kind of the modelers to see what is going on, but it is clear that there is not a very good correspondence between the for this particular area. Well, just to make to finish, what I will show you now is that this is the equilibrium system that we have in the rented area, and this is not only algorithm that deep fields, there are also little fields. So we start by producing a smart field. And it is intended just to control the velocity of the universe. But it is okay for this particular class. But beware, because depending on the use for observation, you will have one value or another. And this is the difference that you can see. So here you can see that this is the difference. So the higher is the value, the higher is the difference between the two. So if you are using a limiter, you may obtain 100 passes per meter more, but if you're using a equilibrium system. And this is not a little thing. So this has to be taken into account. There are some working products that are coming out. This is possible. Some of the possible things that we are not seeing in the same person. Because equilibrium is really sensitive very much the environment, not really maybe something like that. But this is the hot topic. The limiters were normally used by agronomers, auditorium systems are normally used by micrometeorologists, and now orthometrists start using that. They look at these with different perspectives. In this action, orthometrists are working together in our start speaking the same. So this will be my last. But this is for 1 year, the 13th one, in the Ravnice area. And this is just to give you a flavor. That was in that region we have had a severe drought for 3 years. 2021, 22, and 3 years. It was the second year. It was in the middle of the Atlantic. So I think that point that you see the rain event, and in the right side you have the amount of water that rain, and not much. 1, 2, 3, 4. And the gray lines is the industry, and we have our data of water. So what you see is that there is kind of a line of there is kind of a line here between 50 and 65 square meters, which is the natural evaporation that it has. And then when it rains, then evaporation goes up. And in springtime, it rains more often and evaporation goes up, also because we have more wind. This is an integrated way of looking at 1 year data and trying to relate it to the world. I have also the same thing I've done in much more things. And then for the night, also you see that there is condensation 99. Condensation is important at night, so we give this condensation. So modify cooling rate at night. And in this place, it happens most of the time. And it is a difference also between the related zone and the non-related zone, because in the non-related zone, we don't have and the operation zone is good. So it goes down, 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 down. So this is one of the reasons why the related area is covered. Well, that was more already. I wanted to just show you what we are doing now, or the consideration of being too boring. Here are some conclusions. I don't know if it will be made available now. Just to the paper on the right, you did that. Don't use it too much. Okay, thank you.
So thank you very much for your presentation. Very interesting insight of the conservation, population, and all the dilemmas which are appearing in this respect. So I would like to take this perhaps a few minutes for the discussion. If there are any questions from the public, please.
Can show you.
Yes.
So when you show the modeling exercise, there are 2 models, UK methods and KRAŠ. But you also showed the land surface model surface and rules. And I'm just wondering, were you running them as a coupled system, both atmosphere and land surface? And did you try running only land surface?
It was not the model, but it was necessary one. I was not the model, but it was necessary one and pick it on the revolution. I think the other for the whole campaign, and so that it was covered. I must say, you were seeing these things, and the first steps, they didn't have irrigation. They don't want very much. And then they tried to irrigate, and they were irrigating and saturating at the time step. So if it was using water, they were replenishing every time. And this is what the model of so. This is what the results when the model are trying to irrigate. But it is clear now to the problem. And what is happening now is that these people are working offline, then to see what is going on, possibly we observe them now. So I think that is very interesting. For them.
Still some questions from the audience?
I have one more.
Oh, yeah.
I was just wondering when you showed these imbalances, only almonds that is during the daytime showed negative imbalance compared to the others. So I was just wondering, is there easy explanation for this?
We have a tentative explanation on the almond negative environment. So it's because we are pumping water from the ground. So this evaporation is a kind of response to solar radiation. And one of the things that could be playing a role is that the plants, they do not only transpire to grow to generate green matter, but they also transpire to refresh the leaf, especially when it's very hot. So when they start transpiring, just to keep the temperature at a variable value so that they don't get burned. And as much as there is water available, it will transpire just to be alive. And this is used, this is made of the tree to be alive. It is an immediate response to the heating, but not a direct response. So we think that the development response in vegetation, pumping water from water levels, typically one is going to have. But the temperature, then it has to be.
Okay, we will take another one.
So is it really impossible for the water vapor in the atmosphere to condensate on the already wet place? Is that really true?
Can you just?
I thought you said that it's impossible for the water vapor to condensate on an already wet place. Is that really true?
No. If I said that, I didn't mean to. So what I say is that in the vegetated surface, you have normally evaporation and not. That's what you observe. It doesn't mean that it cannot condensate as well. In fact, in the apple orchards are lines, and in the spaces between the lines, which are 2 meters wide, it's bare soil because it's flat. And there you have condensate in this area.
There are still some questions to take into consideration, and we will have a coffee break, and we will have a possibility to discuss more in detail.
Okay, thank you.
Yeah. So now it's my turn. So I've already had the session chair, and also my presentation will pop up very soon. So I would like to take this opportunity to express my thanks to the corporation colleagues for the invitation, and also on behalf of the Environment Agency, I really would like to congratulate you for 9th event in a row for this kind of debate, because it's really missing that we share the knowledge and experiences. So to start my presentation, this is my first slide for another social coming from the Environment Agency. Actually, I'm head of the section for meteorological support to agriculture, and it's very in line with the previous presentation. So I will talk about drought. So restoration is a crucial component of drought monitoring. So and also with my colleague CPT in the public, we would like to show you how we managed to approach to this problematic on operational level. So I will perhaps now show a little bit more how this is working in the operational work of meteorological service in Slovenia. So the outline of my presentation is structured in 4 parts. So first of all, I would like to tackle a little bit also European level, because we are all now members of European Union. So common agriculture policy is also something that we have to follow, and extreme not also affecting our countries, but also the market and the exchange of the products, and of course influence on the prices of the food. So first part, a little bit about the problem, then how what kind of changes we are observing related to the drought phenomenon, which are these characteristics which are nowadays appearing on European or local scale.
Focus of my presentation is drought meter forecast. Actually, new tool that we have established in Slovenia in 2021 with one reason. We figured out that drought is not only an issue which is concern of agriculture sector. It's becoming more and more important also for the other sectors. So therefore, this communication in the field of hydrology and meteorology is not speaking about agrometeorology, is very important. And the final one, a little bit of how we introduce this tool and the calculation of water balance in the drought 2002 estimation. So these are picked up from the European Commission Science Hub, and I would not like to repeat the fact that we all know that the agriculture is every year very turbulent for the agriculture producers, because we have not only the inter-annual weather disturbance, but also intra-annual weather disturbance, which is really causing a lot of problems to our farmers, and of course to sustain the agriculture production in Europe. So these are picked up from this year, and you can see we have a lot of problems with drought, with severe storms, and intervening recently we have a very big problem with flooding. So, of course, we are observing this comments from here at GRC bulletin also what the trend of the agricultural production will be in this year, and they have to correct this year forecast mainly on monthly routine, because the weather is bringing a lot of changes on yearly basis. Okay, but usually when we are convincing people that something is going on, usually we are losing money. So these orange bars are showing us on European level how much money the cost or economic losses are in agriculture sector in European level. And I think that this is more than convincing proof to say that we have a problem on European level, especially last 10 years. The increase of economic losses is really increasing. And then coming to the territory of Slovenia, this is also the case that not only drought, which is marked in some specific years, which are probably relevant also for Croatia, we had in specific years we had a problem with rain, with storms, with droughts. So it's really difficult to say, and we have to speak with our farmers how to adapt to climate change, because we don't have really a clear answer what to do. But the numbers are quite high, and of course you can see these violet bars are showing how much money Slovenian government is giving back to the farmers, and also we cannot count anymore on the governmental support. Probably we have to really encourage our farmers to self-protect with the different techniques and new innovation methods which are bringing also to the science, to the farmers. And here it's not on the chart, it's not presented also the damage in 2023 when we had really this year flooding, which is still not estimated finally. Okay, we already heard a little bit of the concern what the climate change will bring to us. And here I just put one recent result of the study which is been through the European Parliament, and you can see that Southeastern Europe, we can see, and probably your analysis in Croatia, they are showing the same results. That we have trends in the past, the droughts in our region are more frequent, but also the future will bring to us a little bit more problem probably with a quite high likelihood that the drought will be problem with a warming climate as well. But have just one fact which is also interesting for me, that agricultural losses account more than 50% of the total damage on European level. Probably there is a different situation in different countries, but still quite important fact, and also Mediterranean region is even higher. And then what I already said in the beginning, agriculture sector is not the only one that will come and need water in the future. What we have observed in the last years, it was the fact that we had a problem in the energy sector, Also in irrigation problems appearing. Here I have marked the Drypo River. They have really problems to pump the water from the water reservoirs. How to deliver water to the cattle? In some farms, they have problem to deliver water to the pastures. And another thing which is also very important to say, that the agriculture sector, a lot of the first water of our food is going on the rivers. And here, right here, was almost empty during year 2022. And one ship can deliver 1,000 trucks. And you can calculate how this could increase the cost of the food. And also, this will affect our house economy, I would say. Okay, and then what are the characteristics that are appearing on the European level in Slovenia as well? So we have a more frequent heat waves and summer drought, which we are calling these rapid droughts. This is the reality. Then we have a dry springs and opens, which were not they were not so common in the past. And of course, for the water balance, we need also the water balance in the winter time. And you can say that we have this greening period in winter time, so we are running without of snow and with warmer winters, which are not very good for the beginning of the agriculture production. And another fact that I would like to say to you, that we are also confronting in many countries with multi-year drought. Germany, they have drought almost 3-4 years in a row, and also this was the case in Italy as well. So to come to the point, so of course we would like to know exactly in which location, how long and when, and what kind of severity drought will appear. So for this reason, we have different approaches. We have this European level approach, so this is European Drought Observatory, this is a regional scale, how we observe the drought development with different indicators. Then we have some regional ones. Probably some of the colleagues, they are aware of this Auditorium Drought Observatory, which is bringing a lot of different indicators to observe what the development of drought is in the region. And you can see in the beginning of November, we still have some orange parts in upper regions. So the mountain regions are not so, let us say, safe in this recent period of time as this was the case in the past. And finally, this is the focus of our of my speech today, the drought portal for drought future. This is the tool that we established in Slovenia. Due to the limitation of time, I would like to encourage you to visit our webpage, and you have all the methodology explained there more in detail. But just to say very shortly, this is our official year of drought winter. All these three components of drought, they are still there. So agriculture drought, surface water balance, the discharges in surface water, and hydrological drought in groundwater. So we combine all these parameters together with different methodologies, and we put on the same page, let us say, or on the same regional distribution, and we have weekly routine and return data issued for 60 regions in Slovenia, and all the details and description and drought levels, they were on behalf of the colleagues, they are in charge of different parts of the cycle. So this is simply what are the typology of drought and what kinds of variety we are using for the calculation. So for the agriculture drought, which is mainly focused on today's presentation, we are using surface water balance. This is only the simple water balance, precipitation minus evapotranspiration. Related to the previous speaker, we are using Penman-Monteith calculation method, and we are calculating this on most representative stations. For the statistics, I will not go into details. It's simple percentile analysis, and we are using the decline from the reference period. So these are the regions that we are covering. So as I said, we decided with hydrological colleagues to state the same regional distribution, just to have more clear message to the public. So these are just the more detailed descriptions or percentiles. There are different levels for agriculture drought. We have these capitalized, so from green to red one.
And of course, there is also important fact that we have to have this critical judgment by the expert on nuclear routine. I will not go into details, but if you have interest, we can discuss this more in details later on. So this is just one example of how it looks like. So we decided that we will put on one map all the parameters, and also with the prognostic forecast, we are also giving our clients expected trends in the following 7 days. So also the weather forecasters are included in this process as well. Then we also inside we describe a little bit what is the condition in agriculture ecosystem, and of course drought levels, which are described in a graphical way or in descriptive way. And finally, there is a summary joint map where we put all together, and the joint map is representing drought situation, and color of the region is the worst detected drought level and corresponding icon, so that all the clients can see where the problem is. And finally, I am calling this big house, that you can see that how the development of the drought was over the season. So this is the year 2022, and you can see that it started already in spring, and it developed in red traffic light, let us say, in high summer, so that we can somehow discuss with the agriculture advisory service, with the government, and also with the authorities that are, let us say, responsible for the response. And finally, how you can find these tools, you can visit our webpage. This is Meteorology part, and also we have this new tool. It's called Blue Pages, and you can click on the icon to show me, or this is drought meter, and you can find the tool which I was presented to you in the previous slide. And finally, to conclude, this tool is in the improvement process, so we are in constant contact with end users. So of course, we would like to bring this kind of science that it was presented in the previous speech into the drought monitoring. Remote sensing will probably become a part of the process as well. And with this, so I think that communication with the stakeholders is myself with all the products that we are producing in the framework of meteorological service. So with this, I would like to conclude perhaps only one remark to convince you that most of the media has a problem with drought. So our government accepted this tool as a tool for the natural disaster declaration. So as you can see with this bar that they have these charts inside. All these years in Slovenia we declared a natural disaster. And here is also the regional distribution that it's easy also for the policymakers to see which years were really the most problematic, let us say, also for the stakeholders. So you can also find this on this web page, because we are this reporting also to the European Union. So with this, I would like to conclude. Here for some further readings, we have some links to our recent projects, and also for the forecast that I was showing to you during my presentation. So thank you very much for your attention, and I'm open for some questions if there are. Thank you. Any questions? We have technical difficulties. There is no question, please.
Thank you. Interesting. You mentioned in one of your last slides that you plan to use the remote sensing data that's been satellite data as well.
Yes, exactly. Yeah. For this part, when we are speaking about ecosystem now, we don't have really usage remote sensing data. Now we are doing this estimation what kind of data, and the solution will be probably part of this agriculture capital fund. Thank you. Thank you for the question. So with this, oh yeah, there is one. Yeah.
So who are your candidates for the most?
Yeah, good
question. Yeah, Civil Protection Agency, Agriculture Advisory Service, Ministry of Agriculture, Ministry of Environment, and also some research institutions and general public, I would say, especially when we had some problems with water supply in 2022, in the case of the code, we had really problems with the water distribution, because we had to also integrate the fire brigades and water companies. So we are, I hope that I didn't grab too much of the time. So now we have Petra. Thank you. I greet you all and thank you all for coming. But I will continue in Croatian. But if you have any questions, you can ask me in the computer or during the lunch. Drago mi je da je prvo pozitivno predavanje bilo na temi termokonferencija, budući da se ja ne znam njenu. Mogu ste vidjeti koliko je zapravo puno parametara o kojima je termokonferencija ovisi i koliko je zapravo teško odrediti između različitih podloga i s obzirom na navodnjavanje. Danas ću nešto više govoriti o alternativnim metodama za određivanje termokonferencije koje su bazirane konkretno na temperaturi. Budući da je preporučena termometritova metoda od strane KRAŠ, ona se sadrži puno parametara, međutim oni nisu dostatni za određivanje i u komunikaciji sa kolegama iz zavoda čula sam kada nisu svi parametri dostupni, onda se koristi sama organizma metoda. Međutim, mene je zanimalo koje još druge metode su pogodne za određivanje termokonferencije, budući da se moj doktorsko istraživanje ostane na srpske prognoze i na agrometeorološko modeliranje, a jedan od glavnih pogona za model Auditorium je i evaporacija. Stoga je vrlo bitno da imam dobar ulaz kako bi imala dobar izlaz. I s obzirom da su srpske prognoze dosta zapravo nepoznane za ostale parametre, pošto znamo da su da temperatura zraka imamo određen stil, vrlo mi je bitno znati koja od tih alternativnih metoda za određivanje evaporacije bazirana na temperaturi bi bila najpogodnija za daljnje korištenje. I još sam zapravo samo nešto reći. Prema reakcijama za konferencijama kojima sam do sada bila, evaporacija do sada bila dosta nevarivana u modelima i konkretno kolegica iz Deutsche Tardinska također se zanimala za to izlaganje. Oni su također u postupku evaluacije metoda koje bi možda poboljšali njihovu parametrizaciju. Za definisak na to koristila sam takve podatke sa 84% iz naše matične definicijske mreže i od CTS, znači europski definisak koji se puni sa podacima iz europskih, odnosno država, nacionalnih država. I ovdje znači na horizontalnoj revoluciji od 0,7 stupanj. Također gledala sam i European dataset, koji također na istoj jednakoj horizontalnoj rezoluciji. Ti podaci su zapravo već imali određenu korekciju i spremni su za korištenje za meteorološke modele. I koristimo zemljske prognoze, mislim da je na rezoluciji od 1 stupanj. Za period od 1993. do 2016. Tako svi proračuni su za taj period. Ovdje su tako nabrojene metode koje sam koristila. Prva je dakle od preporučena Pavla 56 termometrova metoda, mislim koliko unutra ima parametara. Dakle, Hadeksa Mani, modificirana 1, 2 i 3 Hadeksa Mani metoda i metoda Krajković. To su metode dakle koje se evaluiraju. Na temelju ovih dalje evaluacijskih metoda, dakle koristim ovih 5 metoda za evaluaciju koje model bi bio najpogodniji. Izabiram nekoliko sezona, dakle s obzirom da zemljske prognoze, svi podaci dosta od teka sektora su dakle time series,
vremenski vidovi, ali zemaljske prognoze kad se skidaju, one su zapravo jedno za zemaljska prognoza za siječanj je zapravo za tu godinu, za tu godinu, za taj mjesec, i ono sve sadrži 215 dana, znači prognoze za sljedećih 215 dana, odnosno za 7 mjeseci. Tako da ovo bi bilo zapravo zemaljska prognoza za siječanj, koja u sebi sadrži 7 mjeseci, tako da veljaču kreće od veljače do 8 mjeseca. Zeleno označeno je rezultatski period za jare kulture, to je 2 godine, a ove sezone su zapravo označene koje bi se gledali neki standardne sezone, onda 4 standardne sezone, plus još dvomjesečne sezone za July, May, June, July, August. Imamo i ovu cijelu rezultatsku zapravo sezonu koju nam nadam. Znači, svi proračuni su oni koji se pokazuju za list time 3, to znači za prva 3 mjeseca list time 7 i ovi ostali su list time 2 i list time 3. Ove studije sada nećemo promatrati, oni su također sezone, ali su za maknuta unutar tih 7-mjesečnih prognoza. I sada nisu promatrati. Pokazujem zapravo ovdje kako zapravo izgleda naša kako izgleda naša godišnja oscilacija evapotranspiracije. SRS je referentna, znači Hrvatska izračunata prema temeljnom tipu evapotranspiracije, ona je značajna sa plavom bojem, one su ostale alternativne metode i vidimo manje više dobro slaganje sa referentnom vrijednošću. Međutim, znači, ovo su alternativne metode izračunate na temelju podataka iz Hrvatske. Dalje imamo na temelju podataka od IOS mreže. Vidimo da je zapravo nekako možda kao bolje slaganje podataka sa IOS mreže. I plavo je označeno opet referentna evapotranspiracija za Hrvatske mreže. Sljedeća je AGRA5 dataset i vidimo da svi su izračuni na temelju posakane vrijednosti našli, drugi podaci, znači vidimo koliko zapravo AGRA5 nema dobru reprezentaciju potencijalne prema temeljnom testu evapotranspiracije, ali s obzirom da je ovdje samo temperatura ulaz i eksponičko vraćanje, ove ostale metode dobro pokrivaju referentnu vrijednost. Ovo je bila poslije za od kontinentalnih klime, a sada imamo zapravo srednjske prognoze. Ovdje je za 2010. Srednjska prognoza za siječanj, znači 7 mjeseci naprijed. Plava je referentna Hrvatska i ovo je izračun prema podacima od srednjskih prognoza. Vidimo koliko su zapravo one ne predstavlja dobro i koliko su zapravo pogrešne. Kada uzmemo u obzir alternativne metode, one se donekle približavaju, međutim, početnim mjesecima, međutim, kasnije one nemaju dobar prikaz evapotranspiracije. I kod ovih alternativnih metoda vidimo da se ovdje zapravo tiče NKS1, tako je u osnovnim slučajima vidjela više karakteričnih voda. I jednaki slučaj je za planinsku postaju za oboli, isto je dobro slaganje kod ovih biopskih setova, također kod svih postaja, kod 4 postaja, ERA5 ne daje dobru reprezentaciju evapotranspiracije. I jednaki slučaj kao i kod srednjsku prognozu, znači nije dobra vrijednost, ali i metode zapravo u kasnijoj fazi ne daju dobre vrijednosti. Kod narativne postaje vidimo da zapravo i u slučaju hrvatskog seta, hrvatskih seta podataka, evapotranspiracija nije dobro. Nema dobro slaganje sa referentnom vrijednošću, kad uzmite podatci, jednako tako i za IOS dataset, a još više i za ERO. Ako će biti prognoza slučaj isto još izraženiji, dakle je još niže dolje. Pokazano vrijednostima, a ovdje vidimo da postoji neko slaganje, i ono što bi se htjela dodati, kako sam rekla, licencirano, žalno što bi se htjela napraviti do izazova je downscaling, znači moramo napraviti downscaling temperature, pa onda ćemo vidjeti koliko će se popraviti od rezultata i što će biti bolje stvaranje sa tim vrijednostima, hoće imati neki domaći do toga. Mislim, naravno da hoće, ali pitanje sam koliko. Znači, trenutno postoje program scaling temperature. Ovdje su tri perspektivne toga, zapravo ovdje su za sezonu, znači svi data setovi, za pojedine sezone, ono koje sam se navela na početku, i ovdje možemo vidjeti zapravo očekivano da za sezonska prognoza zapravo ima najslabije rezultate, a u hladnjem dijelu godine isto imamo najbolje rezultate. I ova metoda, zapravo ove dvije su nekako približno, je provalila Trajković, ona ima najbolje rezultate što se tiče kontinentalne, a što se tiče obalne postaje, ova M27 ima najbolje rezultate. Isto tako vrijedi i za Minnesota Europe, znači sezonska prognoza dosta dakle kao što je očekivano. A što se tiče koeficijenta korelacije, jednako očekivano sezonske prognoze za partiju, ali dosta dobro što se moglo vidjeti prema sekunno, jer se ima zapravo najveće slaganje sa referentnim vrijednostima. I na kraju odabir metoda, znači ono što se moglo vidjeti da s obzirom na svaki pojedini dataset, rezultati za metode treba odrediti svaki puta kada se koristi taj odlični dataset, jer ne mora značiti da će jedna metoda biti pogodna za neki dataset za neko područje. Znači, svaki za ovaj naš američku prošlost, Trajkovića metoda u svim ovim datasetima bila pogodna, ali za ovo je bila modificirana adresanalizirana metoda, ali sve se prognozi izgleda da je najpogodnija također u svim kontinentalnim predjelima Hrvatske, odnosno klimatskim predjelima Hrvatske, modificirana metoda. Dakle, zaključak je bio da je odabir i dataseta važan, ali i s obzirom na dataseta koristimo da je potrebno koristiti i vidjeti koja metoda bi zapravo bila najbolja. I ovim putem želim zahvaliti kolegi Danielu Miliću, koji je prije godinu dana dao početni bus, da se obavljam Pythona i sada to vidjeti se gotovo, ali je bila jako teška, tako da bi jako se ne zahvaljujem. I hvala vam.
Hvala, Petru. Thank you very much, Petra. Some questions, please?
Thank you for that presentation. I was wondering, how did you treat the ensemble members in the forecast? Did you work with all available ones? I worked only synthesized I used the mean ensemble. I have calculations for every ensemble, but in this I used the mean ensemble. The mean of the median. Any reason for that? The rational. It was with no such reason, because I don't know. It was just because of the there is no such reason. Do you have any suggestion why? I'm also kind of talking about the same problem from a different perspective, but some argue that by keeping percentiles, median, you put some information on the spread, so you have a view of the Okay, I will take that into thanks to all of course, and we talk about so many calculations and so many fundamental to the new and all this and that. And that's why I wanted to chat later. Sure.
So we have next presenter from Egypt as well, Marwa Amira Al-Mahdi. I don't know if you
Hello, could you
would
hear
you
me?
be so kind and come now it will be your turn. Are you ready to share your screen? Marwa?
Hello,
Yes, Marwa, we can hear you.
could you hear me?
Yes, we can hear you.
Okay, I start my presentation now.
Marwa, you can share your screen. Now it's your turn.
Okay, I share my screen.
Yes, please.
I'll talk about analysis of temperature conditions needed for winter wheat cultivation and the impact of temperature change on its productivity in Delta of Egypt. Now, the study area. Egypt is located between 22 degree and 34 degree to the north of equator in arid climate region according to Köppen classification. Delta is situated in the northern part of Egypt. The size of delta is 150 kilometer to the length, and its width is about 250 kilometer at the coast of Mediterranean. We will study our cases in four sites: Hera, Kafr al-Sheikh, Garbiya, Qalyubiyya, and Sharqiya. Number one, we will talk about analysis of meteorological data in our study site about temperature, wind speed. Number two, we will study the relation between temperature and winter wheat productivity. Three, what is the climate change that's done over Delta in the last 30 years from to 190 to 2020? And the last thing, we will estimate the productivity through 2005 and 2050. Wet is aggregated in mid-November when temperature is about 18 degrees Celsius. Minimum temperature is about 14 degrees Celsius and maximum temperature is about 25 degrees Celsius according to the graph you show now. We harvest wheat in the mid of April. From November, temperature decreases till January. It is the coldest month in Delta of Egypt, then decrease again until the harvest of wheat in the late of April, where temperature is about, when mean temperature is about 20 degrees Celsius, maximum temperature is about 29 degrees Celsius. Now, what's the relation? In Nile of Delta, we irrigate our plant with Nile. So we want to talk about the rain as a factor that affecting the productivity of wheat, according to many studies. And as you show from the graph, that wind speed doesn't significantly change along the season of planting. So the only factor we are interested in is that temperature, mean temperature, maximum and minimum temperature. We studied the relation between temperature and the productivity of wheat along 20 planting season from 2000 to 2020 with NASA power data. We found that there is a very strong negative correlation between temperature and productivity that reached to 0.9 in the 5 sites. With deep analysis of temperature, we found that the most significant month, or we found that our group winter wheat is more sensitive for temperature in February. That's the month of uh, heating and flowering. Now, what's the climate changes that we experience in Delta of Egypt during 1991 to 2020? We shows the time series of mean temperature, maximum temperature, and minimum temperature. As you show from the graph that there's a strong increasing in temperature during that period that have a trend equals to 0.07, means that temperature changed by about 1.4 degrees Celsius during that 30 years. The same for maximum and minimum temperature. So climate change is very rapid and is very strong in our region. So we want to know what's next, what will be the situation for the productivity of winter wheat after or in the next years. We want to use, we want to have a group simulation model to be able to estimate the productivity of wheat in the next 25 years. We use the WOFAST or World Food Case Study model for that purpose to estimate the productivity of winter wheat. First, the study methodology. Number one, we tuned the model to get the best simulation for that model to estimate the productivity in Delta. Then we test the model, and then we used that model to estimate winter wheat during 2025 till 2050. Number one, we tuned the model to have the best values for T sum 1 and T sum 2. T sum 1 stands for the temperature sum from emergence to ancestors. T sum 2 stands for temperature sum from ancestors to maturity. We had 9 different trials for we changed the value for those two variables for about 14 season from 2001 to 2014 to get the best values for them to simulate our group. We have 3 trials with the least relative bias that reaches to about 1.5%. So we test the model against those 3 trials to find the best one that can simulate our group. We found that the best simulation was gained when T sum 1 equaled 1,200 degrees Celsius day, and T sum 2 equaled 990 degrees Celsius per day. So we used that values to be able to estimate the productivity in the next period. In addition to simulation of the final productivity, we found that WOFAST could estimate other variables like leaf area index, development stages, transpiration, and total above ground biomass. So we try to get use of those parameters to be able to track our group and get the appropriate time to intervene uh, and put our group in the right way to get the best productivity. We try to do something like this. We get the leaf area index, the mean of leaf area index during the whole period from the 20 years from 2000 to 2020. You can see that the mean leaf area index and its standard deviation is drawn as shaded area. The black line in the top of the graph represents the behavior of leaf area index when the productivity was maximum. And the red line, it represents the leaf area index when the productivity is the lowest. With that graph, we can track our group during the planting season and identify whether our group is in the mean track for productivity or it's something wrong if it's in the red line. So we can intervene and do actions that can put our group again in the right way. The same thing we did for development stages, top above ground biomass, and finally to the transpiration. But the transpiration wasn't very good to achieve our goal. So we can bend on leaf area index development stages and top above ground biomass graphs. Now, our question is what's next? What will the behavior of our group in the next 25 years from 2025 to 2050? We used two representative concentration pathways, RCP 4.9, that's the midway, and RCP 8.5, the most pessimistic pathway. According to RCP 4.5, we found that temperature will experience an increasing with about 2 degree, with about 1.6 degrees above the climate change that already happened during the last 30 years. That will affect our group with decreasing its productivity by about 11%. According to RCP 8.5, temperature will experience more and more increasing in temperature that will reach to about 5 degrees in that period from 2025 to 2050. That will affect our group productivity and decreasing the productivity with about 27%. Means if we take that pathway, we will lose about 1/3 of our productivity in Nile of Delta. Thank you so much.
Thank you very much, Marla, for your presentation. It's really shocking how the youth will decrease due to climate change in your country. So are there any questions in the audience? Not really. So thank you for your presentation once again. So I would suggest a little bit of change of the agenda. Meanwhile, we will arrange this communication with Semi. So I will kindly invite Natasha Markovic will present to us UMESA's second products in the support of meteorology. So I hope that the presentation will appear, so we are lucky now. So thank you, Natasha, the floor is yours.
Dobar dan svima. Pričat ću na engleskom, tako da me razumiju i oni koji nisu iz Hrvatske, ali drago mi je vidjeti vas u tolikom broju i drago mi je vidjeti drage kolege i prijatelje. This will be, good morning all. This will be a more of a overview presentation, so not a lot of science. So there are a lot of products also from satellite that can be used in agrometeorology as they can be used also in other regions of science. So actually, I will tell you a little bit just about UMESAT and how the SAT network works, and then I will show you some of the LandSAT products and some of the HydroSAT products that can be used in support of agrometeorology and agronomy. So, because many of you probably already know something about it, UMESAT is an organization with 30 member states. One of them is also Croatia, and you can see these are all European Union countries and some plus. So is a member of EUMETSAT, and actually the main goal of the organization is to establish, maintain, and exploit European systems of meteorological satellites, and by this contribute to operational monitoring of climate and detection of weather and climate, and also detection of climate changes. Currently, EUMETSAT operates 10 operational satellites. 4 of them are in geostationary orbit. These are the lower 4 ones. 3 of the Meteosat second generation, and our newest satellites of the first satellite of the third generation of geostationary satellites. And then there are 6 polar orbiting satellites also operated currently by EUMETSAT. Our newest MTG satellite is currently in the commissioning phase, is about to become operational very soon. But what I wanted to show you with this slide is that we have a lot of satellites in the orbit, and you can imagine that these satellites produce vast amounts of data on a minute basis. So the reason that EUMETSAT actually organized the SAF network was to best utilize all of this data coming down to our reception stations. And the SAFs that have been organized many years ago already, some are older, some are newer, are actually the facilities organized by the member state countries, which are responsible for the research and the development and all the operational activities, and they actually are in charge of producing new products and new applications of the data that have been received from the satellite. As I said, the SAFs are located within the National Meteorological Services of EUMETSAT member states or other entities within the member states. Currently, we have 8 SAFs, and they provide data. They provide users with operational data and also software products. And each of the SAFs is dedicated for a certain application area. Since today we are talking about land, so agrometeorology and land use, the SAF that is actually in charge of that part is Land Surface Analysis SAF. It provides an in-depth look at the Earth's surface, including vegetation and also wildfires. It uses satellite data observations and offers vital information for agriculture, forestry, land use planning, and also disaster management. So the parameters that are analyzed by the SAF products you will see are evapotranspiration, for example, also fire detection, land surface temperature, and all of this supports monitoring and prediction of environmental changes. So just a few words of the type of the data. So the products, the Landsat products are grouped actually in 3 different groups, products related to radiation, energy balance, and vegetation. You can see here the products that I have selected. There are more than this, but these are, let's say, more or less something that could be used in support of agrometeorology. So first of these products, maybe not the most important, but first is the land surface temperature. This is radiative skin temperature or surface temperature over land. It is the product that is available from both polar satellite data and geostationary satellite data. When you look at the polar satellite data, this is the product that then comes with the overpass of the polar satellite. So probably with each satellite about 2 times a day over a certain area. Whereas and has a little bit better spatial resolution. With the geostationary data, this is a product that you can get every 15 minutes. So you can get land surface temperature every 15 minutes. The resolution of the geostationary product is in the sub-satellite point, which is approximately 0 meridian, and the equator is 3 kilometers per pixel. In our area, it's about 4.5 kilometers per pixel. So you have this good product every 15 minutes for the land surface analysis. What is here on the right-hand side is an example of the use. So the example shows actually frost damage in spring 2021.
In early April 2021, there was several days of frost, which was monitored by the satellite product that affected Central Europe, which actually happened following the enormously warm March. And this led to severe damages, especially in vineyards and fruit growth, so orchards, where actually a lot of plants were damaged severely by this frost, and this could be monitored by the product. This is just an example of the use of the land surface product. The second type of product is evapotranspiration. You heard a lot about evapotranspiration in the previous talk, so I will not explain what evapotranspiration is. So here, actually, what is important to say that evapotranspiration is, as you saw, dependent on the solar radiation. It's something that then makes it very dependent on the latitude, season of the year, time of day, and also cloud cover. Evapotranspiration from the satellite is available in form of instantaneous evapotranspiration. So again, you can have a product practically every 15 minutes. And there is also daily integrated products. You can have a daily average or a daily integrated evapotranspiration product. Another product which is also connected and was also mentioned before is the reference evapotranspiration. There's the right-hand side. The reference evapotranspiration is calculated, is actually calibrated in a way that it uses the grass surface with the grass 12 centimeters high. And that's how actually the evapotranspiration looks in a reference mode. It's a theoretical evapotranspiration and represents the evaporative demand of the atmosphere. And what is actually good to monitor the difference, of course, you saw it also in the previous presentations, but I also have an example here from the satellite. So here on the left-hand side, you have a reference evapotranspiration map for 15 August 2020 over Southeastern Europe. And you have two markers pointing to the two cities for which you see the graphs on the right-hand side. So actually, on the right-hand side, you can see time series of comparison between the daily mean evapotranspiration and the reference evapotranspiration for the whole year. And actually for 2 years, 2013 and 2020. And in the red ellipses, you can see the periods where you had very large discrepancies between the daily mean evapotranspiration and the reference evapotranspiration. Reference is in black, daily mean is in blue. And this periods when the reference evapotranspiration is much higher or the mean daily mean is lower, indicate very strong water deficit. This is a product that then can be used for the support of, I don't know, irrigation methods or whatever the agronomers do, but just to see that something like this is available also from the satellite on a regular basis. There are also vegetation products. These products are describing the state and health of the atmosphere. There is a whole list of products. I mentioned here a few. There is leaf area index, which defines the area of green vegetation. Then there is the fraction of vegetation cover, the partition between soil and vegetation, and also fraction of absorbed photosynthetic active radiation. I'm not an expert in vegetation products, so please don't ask me any very difficult questions. And then there is also a normalized difference vegetation index, which can be also seen on the right-hand side. So the image on the top shows the normalized difference vegetation index, the 10 daily products. So the products are available on again daily or 10 daily sums, and also the lower one is the FAPAR product. Again, an example of the application. On the right-hand side, you see actually the fraction of vegetation cover, actual and reference evapotranspiration. And also the different drought levels have been marked. This is a situation over Slovenia, because Slovenia is the member of the LANSAF, so they do a lot of products and they do a lot of comparisons. And there was a moderate drought occurring in summer months in 2017, and you can see how the products behave in this area. So this combination of satellite evapotranspiration and vegetation signal is advantageous for drought detection, because when you look at the evapotranspiration, it will first show the lack of water. But then when the vegetation also shows the sign of the drought, then you have the proof that the drought is really severe. So when the both products are showing the drought. On the right-hand side, there is another example. That's in the upper part is the fractional vegetation cover product. Again, this is the anomaly for August 2020 as compared with an average from 2004 to 2017, and you see that the areas which are red and yellow show the areas which are already affected by the drought. And in the lower part, you can see the year of 2020. For the spot marked by blue in the upper image, you see how the fractional vegetation cover follows. So actually, first you had the boosted vegetation. So the blue is above the blue is about the average for the longer period. Then you had a lack of rain and the vegetation is dropping. So you have a lot less than the average. And then again, some vegetation boost in June. But what is most important, by the end of the year, if you compare the value of the fractional vegetation cover actually the one in October is the value that was very, very low. So actually something that you would have in August, that you had in August, you would normally have in October. So the vegetation dropped down very rapidly. So this is just again an example of the application. Besides LANSAF product, there are also HydroSAF products, so the hydrology SAF products, which also can be used in support of agrometeorology. These are products connected to precipitation primarily, so they're observing and analyzing precipitation, soil moisture, and also snow, and can help in flood forecasting, but also drought predictions. So here you have two products connected to precipitation. This is the first one is instantaneous blended from low Earth orbiters and geostationary products, and then you have also accumulated product. And there are also other products, like, for example, soil moisture products that you can also use in the agrometeorology applications. So this was just a very quick overview. All the data are available freely from the internet. So the LANSAF data from the LANSAF page, the HydroSAF data from the HSAF page, and all the data can also be searched through the EUMETSAT navigator, so the EUMETSAT product navigator, where you find also many other data, not only the ones that I showed. So this was a very short overview, and also all questions, not to me, but to other colleagues that are very well in this products as well, can be put to training at eumetsat.int. Thank you.
Thank you. Thank you, Natasha, for this very comprehensive overview what really these new products are bringing to agrometeorology. And I have to admit that we are using this and we are looking forward for some better resolution, time scale and spatial resolution. This will really bring a new knowledge and new information to our products. Are there any comments or questions from the public? Not really. Obviously, it was very impressive. Oh, yeah, there is one.
Thank you. Thanks for the nice overview and presentation. I was wondering, do you have an in-house program for evaluating the skill of the products compared to alternatives from different sources?
Yeah, as I said, I'm not an expert in these products, but I know that the SAFs, the organizations I mentioned, they do validate, and they also do all kind of calibration using the regular measurements or the model data. So they do the calibration regularly.
Okay, thanks.
Something to add? Not really. So thank you, Natasha. The presentations will be available. So all these links to the product and to the information, they are available on the presentation. So now we have the presentation from Elena Tarnavsky, and I would kindly invite her to come and to give a presentation. The title of the presentation is Agrometeorology in Action. So challenges and opportunities in the operational use of agrometeorological data sets for early warning and crop yield forecasting by diverse stakeholders. So please, Elena, the floor is yours.
Okay, it works. Thanks so much, first of all, for having me here. It's also an overview presentation, no deep science to digest before lunch. And I will give you an overview of the project in which I'm based at the European Commission's Joint Research Center in Ispra, in Italy. I'm in a unit dealing with sustainable resources and food security. And the project is called Agri-Forecast, which we heard a very nice definition earlier from Andrea's presentation from the JRC Science Hub. And this is essentially what we do, hence my title, Agrometeorology in Action, because the key for our activity is that we do operational agrometeorology and work on crop yield forecasts on a monthly basis. Okay, so I'll quickly go over the objectives of the project, the key outputs, our main monthly output, the Europe Bulletin, mentioning some other activities, and then focus a little bit on the content of the bulletin in terms of areas of concern and how we synthesize and present the information, and then look at the operational system and the meteorological database that underpins the system for the, arriving at crop yield forecasts, as well as some of the ongoing quality control and evaluation activities that we carry out at the moment. And then I will briefly close with some challenges and opportunities that we see in these developments. So first of all, the objective of the Agri-Forecast project, as I mentioned, is to provide timely, independent and accurate information on the growing conditions, as well as early warning information and quantitative crop yield forecasts. So we do this for the main crops grown in Europe, as well as the neighboring regions. We also provide ad hoc advice and reports, analysis based around thematic requests. And this is key because it goes beyond agrometeorology at this point. So for this, we usually look at extreme events, anomalous conditions, explaining this and translating them into impacts mainly on agriculture. But as I mentioned, it goes much beyond, so it's not restrained within this area. We also carry out research and development activities. So in terms of monitoring, developing new data sets, analytical tools, software, and everything is the key activity as well, because the whole JRC provides science for policy. That's the tagline. So any science that we do is of societal importance. And I am fairly new in the team as an agrometeorologist, but the team has been producing the bulletin since the early 1980s, so more than 30 years now of operational analysis. Oh, okay. Didn't mean to go to the end. Not quite yet. Okay. Yeah. Okay. So the key outputs, the JRC Mars Bulletin, so nothing to do with the planet of Mars, but Mars stands for Monitoring of Agricultural Resources. The acronym somehow stuck with the group through the years. The main output is a Europe monthly monitoring bulletin, but as I mentioned, we also look at neighboring regions. In the past couple of years, Ukraine has come into the spotlight, but there is also North Africa bulletin, there is Turkey bulletin, and Russia and Kazakhstan. So these are issued two times per year for those 5 regions. We also have the Mars Explorer, which provides up-to-date information online on the growing conditions, again, for crops in Europe. And this is on the right-hand side in the Agri-Forecast portal. There is also a resource section in which you'll find a lot of the data sets and models available to the public. Some videos for wider dissemination, so in a more non-jargon language, and they're frequently used for educational purposes as well. And all of our scientific publication, technical reports, and any thematic documents. In terms of the monthly Europe bulletin, the main section that serves as a kind of a synthesis of all the information is the areas of concern, and I will show you what it looks like. The other important sections are the agrometeorological overview and the forecast, with interpretation also of the seasonal forecast every month. And then we have a seasonal review, so 4 times a year with the standard June, July, August, September, October, November, the standard 4 seasons. We also provide a seasonal overview. There is a section on grassland and fodder monitoring. There is remote sensing, so much to do about the observed conditions of vegetation using relatively standard indices. There is season-specific analysis, so we look at sowing conditions depending on what crop, what month of the year it is. Some of these sections are in the bulletin or not. There is a harvest update analysis on frost kill damage. And there is also country-specific analysis at the administrative level, so maps and graphs for every country in the Union and the neighboring regions would be also included in the bulletin. And finally, there is a quantitative national yield forecast. So there is a table and map as well with assessment of the forecast relative to the last 5 years, last 10 years, and so on. So the area of concern section that I mentioned is a fairly simplified synthesis of the bulletin content, which we present to our agricultural directorate every month just before the bulletin is published out to the public. Synthesizes the extreme events, or not so much extreme, but anomalous events, things that we find deviate from the long-term average and are sort of untypical. So maybe unfortunately, since the time I've started, the map has been quite busy, as you can see. So the example I have here is from the latest bulletin, so for the last month, because we produced the November bulletin next week. So this is for October, and in most of Europe, we have seen temperature accumulation surplus, so the orange dots. There has been rainfall deficit as well, overlapping with that, creating challenging conditions for the crops, clearly. And then we've had flood impacts on summer crops, for example, in Greece, because there was one of the main agricultural regions was severely flooded. And rainfall surplus in the south of Finland, which was translated to impacting on winter crops. But on the right-hand side is then the areas that are adversely affected in terms of crop damage. So not everything you see on a weather map is directly translating into a negative crop impact, because sometimes the effects of anomalous weather could be beneficial for the crop, depending on the stage of development and so on. But this is how the information is currently summarized, and we are continuously working on improving the communication, because this is one of the outputs that gets most often quoted in media reports and things like that. So this map often appears in the media as well. Now, the system that underpins this entire work and has underpinned the work over the years of the activity in the team is quite complex. But on the other hand, it's very similar to what you would imagine for any kind of system that wants to look at crop yields. So it starts with a weather monitoring component. There is a crop simulation modeling part. There is statistical based forecasting using time series and previous crop yield production statistics. And of course, there is also remote sensing for the vegetation part of the monitoring. So we refer to it as the JRC Mars crop yield forecasting system. And again, it's very well documented in all the online resources about the group. But essentially, it's a data and model-driven decision support system that evolves as the activities within the group evolve. So at present, we are looking at 15 plus crops for the 27 EU member states, plus 7 other regions that I mentioned before. And one of the key aspects is that the system has to be live 24/7. Everything, databases, software tools has to be active, and each crop yield forecast then requires analysis by an analyst, usually crop analyst, and for the agrometeorology, my analysis goes into that. To have an expert judgment and to make an informed decision about where to place the forecast and evaluate the deviations from previous forecasts. So the fact that the challenge in a way that we always try to use the latest available observation then limits the time available that we have to write this. So even though the bulletin is published once a month, it doesn't mean that you have all the data and everything ready and you can do the analysis during the 3 weeks before you have to publish a bulletin. But we wait for the latest available information, from which point there is very short time to get into action, to interpret this information and to prepare the entire content of the bulletin, because there is a processing lag from getting observations, ingesting them into the system, and all of this modeling that has to happen as well. So the trained and skilled analyst is quite key in this component. It's not something AI-based and fully automated, at least not yet. So in terms of, I'll focus a little bit on the meteorological data, so the weather monitoring that underpins the entire system and is the starting point. We work with daily weather observations from about 5,000 stations at present across the European geographic window. It doesn't mean that they report all the time and every day and every single variable. As you know, there are issues with missing data, failing stations, and so on. But they go through a rigorous quality control. We do this by a software developed particularly for our purposes. And they go to procedure for spatial interpolation to 25-kilometer grid scale. Now, at the moment, we are preparing to transition to 10 kilometers. So that's one of our current challenges, very active at the moment, looking at discrepancies and consistencies and whether we are doing a good job in terms of increasing the spatial resolution with the available data, because we don't get more stations or more dense stations, but we have to work with the same amount of data. So this goes into an archive, which starts from 79, but it is considered more reliable since 91. So we use the 91 as a starting period for our long-term climatology to derive anomalies. So we look at long-term for 30 plus years now, and then we look at the most recent 5 and most recent 10 as more representative of conditions in closer years to the current analysis. And all of this is consolidated into the grid scale, and it's available online. through the Agri-Forecast portal that I mentioned earlier. So just to give you a flavor of what it looks like, if you haven't come across one of our bulletins so far, there are staple indicators, and two of the staple indicators that we use every month is the average daily temperature anomaly. So this is a map of the anomaly, and the rainfall anomaly as well. So from the I did this before I left the office, so it gives you an indication of the date. So on the 14th of November, I could produce the map for until 12th, because I have 2 days lag time between the data arriving in the system and my ability to generate the graphs and interpretations. And the station points are just overlaid to give you an indication of more densely and less densely instrumented areas. We don't publish the bulletin with the dots because it just obscures the content and distracts from the point. But here I'm giving you an example of where you might expect to have improvements if there were more spatially dense data ingested into the interpolation. And this is done according to the long-term climatology that I mentioned, so the more than 30 years at the moment. This is what the LTA stands for. And it's still at the 25-kilometer resolution until we switch to the next one. Now, as I mentioned, it's the metal data goes into, at station level, goes into a rigorous quality control. We also do evaluation, and I'm not going to go into the details, but I'm currently looking to evaluate how the gridded data is performing relative to the station level from different alternative sources. So if you can't read the labels, these are ERA 5 land, alternative methods of gridding the data, the EOPS data set that was mentioned also in one of the morning presentations, another one from the flood forecasting JRC division called EMO, that looks at extreme rainfall. But this kind of summary statistics give us a first view of how the data performs relative to other alternative products out there. And this is again a map of correlations, and we produce the same maps of root mean square error for a country-based statistic and for the entire European window. So really, this is all I had to present to you today. Just summarizing with some challenges, we are continuously improving the database. Of course, more data is expected to improve the quality of the gridded products, but also the quality of the data matters. It doesn't mean that where we have a lot of stations, everything is perfect. On the contrary, there are some not so densely instrumented areas, but the data is very good and the time series is great and it works for the purposes. So in terms of homogeneity, consistency, and the methods for spatial interpolation, that's always an ongoing challenge, because any research that we do then enters a stage in which it has to be made operational. So it has implications about calculating long-term averages from a data set that is regenerated according to the latest method that we decide to implement. So we acquire additional observations on an ongoing basis, and we do this software development for quality control and evaluation, again, more or less on an ongoing basis, periodically running these evaluations. Does that mean that we have better country and crop-specific yield forecasts for all stakeholders and everything is perfect if we overcome these challenges? I'm not fully convinced, and I would actually argue that every challenge that we have works in a way that it presents us with a new opportunity. So at the moment, we have the challenge of increasing the resolution from 25 to 10 kilometers. It's an ongoing thing, but it is creating new opportunities as well, because then we can look at more detail in some areas that 25 by 25 grid was insufficient because of the heterogeneity of landscape within. We have also expanded to new application areas. So on the right-hand side, I have, on the left-hand side, I have a map of the new section of the Mars Explorer that we developed last year, and this is to look at, we had a request for assessing the agrometeorological risk for fruit flowering, particularly of apples, but also fruit and vegetable are of interest to our Directorate General for Agriculture. So we're expecting more requests in this area, and we have developed a mask of the main regions that are under apple tree production. And these are some of the indicators that are key, for example, the number of cold days during flowering and so on. And this allows us to have a timely response for ad hoc requests. So last winter with the fuel crisis, we used the meteo database outside the domain of agriculture, but more to look at energy, heating, cooling days, and so on. We're integrating seasonal forecast, supporting climate impact studies, and have a continuous role in this community where we see it as a two-way interaction. It's never just one-sided because every member state collects data, and then we strive to produce a value-added data set that could be used by very diverse stakeholders. Thank you so much.
Thank you, Elena, for this presentation. As I already said in my presentation, that we are looking closely to your products because we would like to evaluate how concrete they are also and useful are for Slovenian agriculture as well. So it's great that you said that it's a process of improvement and we are willing to cooperate in this field if there will be opportunity. Are there any questions related to this yield forecasting? Not really. So thank you, Elena, once again.